So right when we get building permit for any one of our builds, we get handed the keys from our client. We change our locks out immediately to our own locks, and these are a special type of lock, multi-locks. They're like the industry best. They can't be duplicated, and you actually have to go to the locksmith who made them. So all of our trades actually have these locks, and they're all categorized and serial number recorded. So we all have the same keys, and they open up all of our jobs. As soon as the job's over, we take out our job specific lock and we put in new locks for the client. So they have a new set of keys and a new deadbolt, and everything's good to go. In this location, this one's getting ready right now for cutting. This is a slab on grade. If you were to cut this slab open, there would be dirt and gravel right below this concrete. So this is the one of two types of concrete slabs that we talked about. The other one would be suspended, so there would be a parkade or another unit below us. In this case, because of the amount of dental services and plumbing, so sinks and toilets and everything, we actually are going to cut a 2-foot trench outlined by these orange dashed lines. So you can imagine just the amount of weight of concrete that has to come out of here. We mark the thickness of the slab right here. So this slab is between 5 and 6 inches thick. We've had this laid out. We've had all the walls laid out as per the drawings. We've laid out all of the equipment with templates. We've determined where all the services need to go. We've laid out our trench lines, and then the last thing we do before we cut is we bring in the scanner. So they actually scan the slab and they x-ray it to see what's in there. So right now we can see what's in the slab. They mark it out for us. They're able to find structural steel, pipes, electrical, and those are things that we have to obviously avoid when we're cutting through the slab. Right here, this could be an electrical or a plumbing conduit, and it's 5 inches deep. So this is actually going to be inside the concrete slab. So we'll have to leave this section of slab intact, and we'll have to undermine underneath that with our new services. All of this concrete has to get cut out, get taken out that door, removed from site. We have to excavate all of these cuts about 2 feet down to be able to get our slope for our sanitary drains. Once all that plumbing gets installed, we get it inspected, we backfill it a little bit, then we come in and we do our electrical services on top. So we run 2-inch conduits to the toe of the chair, to the side cabinet, to the rear cabinet, so everything's interlinked. And we also run some power to like the reception desk or anything else that's freestanding. Once that's done, we get that inspected, then we backfill it. Then we drill dowels in between the slab here and here, just to make sure that when we pour this chunk of concrete in and it's newly compacted soil, that this section doesn't sink down. Because we're putting on LVT vinyl floor, we don't want to have a depression in it in 5 or 10 years. So we actually drill dowels in all the way around, put a vapor barrier, get it inspected again, and then we bring in a concrete pump truck and fill this whole trench back up with concrete. So that process takes approximately 4 weeks compared to just drilling 3-inch holes everywhere where required. People can be working above, doing steel stud framing or doing HVAC or doing things like that, while the plumbers and electricians are below doing their services. So it's a lot quicker. We can typically do the underground for a suspended slab and have it complete and inspected and ready to go in about 2 weeks compared to 4 where nobody else can be in. There's a lot of obstacles in this slab. Like here, this most likely be a main electrical duct bank running through the whole building. So this is going to be feeding all the electrical panels to all the suites in this space. They can usually see electrical lines with a different type of scanner a lot easier. So I believe these ones are 600 volts, so we definitely have to watch out for those when we're cutting. Definitely a lot to watch out for. Right here, this is our main sewer in this space. In this space in particular, they didn't supply a bathroom. A lot of the time when you get in a new space, they'll have some sort of like an accessible bathroom or an existing bathroom rough-in that we can tie into. This one is a main sanitary sewer running between these 2 demising walls through the entire building. So we have to dig down. I think this one's at about 4 feet down. So we have to cut that open and tie all of our sinks and toilets and everything into this one main drain. Ceiling heights in this unit, we try to keep ceiling heights in operatories no more than 10 feet. A lot of the ceiling mounted lights that you see, like dental lights, are restricted at about 11 feet, so 10 feet is kind of that happy medium. You have to remember that a lot of these units are designed heating and cooling based on the volume of air inside the unit, not necessarily the square footage. So they're looking at the volume of the air. So the higher the ceiling, the more heating and cooling requirements you have, and the less efficient that space will be, because now you have that much more volume of air to condition. So we try to keep the ceilings as high as possible to get the look that you're going for, but as low as possible to ensure that it's going to be a efficient space. What we try to do is make the hallways and the reception area with the higher ceiling to make it look more grand and more open feeling, and then in the operatories, like 10-foot max, especially if you have ceiling mounted TVs, you don't want to be looking up too high. We have done higher ceilings. I mean, that's really all it comes down to the designer or the. This is going to be our main mechanical room. We're going to have our vacuum and compressor set up in here. The vacuum is sized per operators. So this clinic, I believe, has 8 operatories. That doesn't necessarily mean there's only going to be 8 operators. Some devices actually are considered 2 operators. That just depends on how much suction they require. This setup here with the electrical, we're seeing this a lot more common now with developers. They're actually bringing 600 volt to the space, so that would be this main panel here. This is a lot more common with developers today. They're bringing in 600 volt 3-phase services into commercial spaces, which allows them to run a smaller conduit and a lot smaller conductors, so they can actually run further distance, smaller wires, which is less money for them, from their main electrical room to the commercial retail unit or CRU. Put a 600 volt service in, which is great. However, we don't really have anything in our space that requires 600 or 347. So they install a transformer. That transformer drops the voltage down to 12208, 3-phase. This one is, it says 250 amp plugs, but it's actually not. You would have to look at, so we have 60 amps coming in at 600 volts. The size of the kVA of that transformer is actually going to determine the usable amperage at 12208. So that one doesn't actually have a main breaker on it. Those transformers, the developers or the base building will have them sitting on the floor. Now, as you know, square footage is at a premium. We always try to take those and hang them like you see here. Another thing is they don't typically put in disconnects. They'll put in electrical panels. So a disconnect is a lot smaller, and we can actually have a little bit more usable wall space. So what we usually do is rip out the panel and we put in a disconnect for that transformer, and then we're only left with one panel. This panel is only 42 circuits. You can put mini breakers in here that are split. We like to see 84 circuits minimum, and I don't like the mini breakers as much. So this panel will get replaced once we do the build out in here, and this will become a full 84 circuit 12208 panel. In this case, we probably won't be able to change this out, because right here you can see 60 amps is feeding that transformer. So I don't know what the kVA that transformer is, but right here where it says RTU 710, so that means that you have a rooftop unit that's providing the heating and the cooling to the space. That's running at 600 volts, probably for the fan. I think it's gas fired. We'll go and double check that. You definitely have to look at, because now you're taking your 60 amp at 600 volts and you have to derate that because you are using 20 amps of that for your rooftop unit. Might not actually be 20 amps, but we have to take and consider the full load amperage of the rooftop unit and minus that from the main breaker. Right here you have your base building supplied communication. So you're gonna have one pipe is typically for cable and one's for telephone. In this case, the services kind of are back and forth. Like here we're dealing with TELUS and Shaw. So one will go to a Shaw room and one will go to a TELUS room. It's just whatever the client decides to go with for their provider is what they'll pull in. In this building here, we have a roof above us. So this is actually a fire retardant spray. It's going to get disturbed during construction. This is actually something that costs a decent amount of money to repair and replace once we start doing our work. We're gonna have a lot of services that are gonna be hung from all this structural steel, and we have to bring in a crew to replace all of that fire spray. Something to consider in this space. I mean, we do have a lot of ceiling space to work with, which is good. Our main water supply right here will be sized based on the engineer's requirements for the amount of sinks that come into your unit. Right here, I believe that's 1.25 inches, which typically is good. This one has a meter built onto it. So this suite will be independently metered, and you'll probably be billed accordingly from the municipality. Right next to it, that black pipe there, that's a sewer vent. That's important too. All the sinks and everything in the unit needs to be vented in order for it to drain. Sometimes those are missing and it can become a real pain onto like where to find it. Sometimes the base building or the developers don't put them into your suite, and I'll show you an example of that on one of the next practices we go to. The neighboring suites don't have a vent, so now they have to come into our unit after we're done and tie into that vent. We have sprinklers running in the suite. These are installed as per code at the time of the building permit. So right now they're all facing up. The head counts and the spacing is all based on the square footage and the plan right now. We're gonna change those all. We're gonna put a drop ceiling in. Those all have to get turned and drop down into our T-bar or into our hard ceilings, but they are in place. That's something that we need to consider. It's gonna be a service that we have to modify. We also have right here are the supply and the return ducts that go up to the rooftop unit that we saw in the electrical panel. So that's going to be supplying hot and cold air down from the roof into the unit. We'll have to put in distribution ducting that's tied into that. Those will be all the diffusers that go into all of the ceilings for the operatories and the hallways and the reception area. And that's going to be your climate control, so you're hot and cold. In this case, you're only going to be single zone because we're not able to control the temperature between the back and the front of the office. We're limited to one unit in this space. It is 60 amps, as we saw. There's a gas line there. That yellow tape tells me that that's a gas line. So we have a gas-fired rooftop unit. Electrical-wise, that might only be the condensing coil for the air conditioning and the fan in there to actually blow that air into the unit. In this space, we actually don't have an exhaust louver. So a lot of the time in the windows on the front of the building, you're gonna see an intake and an exhaust, and they're separated. We have a dental vacuum in this space. It's a dry vac, and we have to run, I like to run a 3-inch vent from the vacuum all the way to the exterior of the building. It cannot be tied into that vent that we just saw. That is strictly for sewer. The vent from the vacuum is actually pressurized, and we can't put it into the base building venting lines because it's a pressurized vent. So that has to be vented independently. Typically, we'll go outside of the unit. We try to keep distance away from the front door or any neighboring suites. In this case, we might have to go at the back of the building, which might be a better option. There are options to use a ventless kit on a lot of the new vacuums. However, they have a filter that needs to be replaced often. and that becomes just time consuming and costly over time. So if we can vent it, we always try to vent it. We also want to take out any of your exhaust from your bathrooms, which I don't want going through the return air plenum, because that essentially just ends up coming back into the unit. I want to go on the outside. So that again will probably end up going out the back of the building or the side. That's kind of, in a nutshell, some things that I look for when I come into a new space. This one, it's a great space. I think it's going to work out really well. One of the challenges is, of course, it's slab on grade, and we are dealing with a single entry door. Luckily, this one's on a large open parking lot that we're able to put a big truck out there to get all this concrete out. This one is going to be a good office.